Hello, this is the last video in our series. We are finally going to compile our code. It will work similarly to the previous video where we just printed our code, but this time we will actually generate C code and feed it into GCC compiler. Transpilation is always a recursive procedure. We need to traverse the abstract syntax tree from its root to its leaves and slowly generate the resulting string. So the first and most important method that we will need to add is this. Compile to C. It takes a list of statements, it takes string builder, and it creates the resulting C source code in the string builder. So the way it's implemented, it iterates every single statement and it just compiles it to C. Now the interesting thing starts here. The statement itself is an interface, and this method has multiple implementations depending on which node in the abstract syntax tree is currently being translated. For instance, if the first statement is if, then we will run this piece of code. You can see that it's quite simple. All of these methods are just templates for C code, with some of the missing places being generated elsewhere. For instance, here, the contents of the if statement are generated in this function call, and the statements that should follow the if statement are generated here again recursively. Here below you can see how it looks for the while. It's basically the same. Instead of if we have while. Now interesting thing is here, the assignment. C is not like Python or JavaScript. We cannot just start using variables out of the blue. They all need to be declared, and they have to be declared only once at the beginning. So the solution to this problem is to collect all of the variables as we parse, and then before we start calling all those methods, we first generate something like a header, let's say, that contains all the declarations, and then we put the actual code. After assignment, there is also read. This one is very simple, but it calls lots of methods. Essentially, it would be enough to just call scanf function and read some variable. However, to make the user interface a little bit more comfortable, I added here first a printf statement that asks what is the value of some variable and then flashes it to standard output. Print statement is also very similar. It just prints value of some expression, which is transpiled here. And to make it somewhat easier to understand, I also added here some information about what actually we are trying to print. Yeah, so that's basically it when it comes to statements. Now, if you look at the arithmetic expressions, they also follow similar rule. There is the arithmetic expression interface, which has this one method, and it's implemented by all of the possible nodes. For instance, here the plus operation is transpiled into C as follows. It's very simple and straightforward. Minus operation is very similar. Multiplication is also similar, except that we need to pay some attention to respecting the associativity and strength of binding of various operations, so we need to put brackets whenever necessary. The transpilation method is essentially very similar to the previous toString method. Division is implemented in a very similar way. Unary minus is also very straightforward. There is not much to worry about. The variable is just a simple string. Integer, it just prints integer value. Logic expression, it looks also very similar to the toString function. It's almost the same. Now, the greatest difference appears in the main method. Here, the beginning stays the same. We just parse the grammar and collect the output. However, we also need to collect all of the used variables, so the listener is slightly modified. Apart from statements, arithmetic expressions, and logical expression, it also now has something like variables required. If you look here, it's only used in two places. Here, where we read something, and here, where we use variable in an arithmetic expression. And also in this one place where we assign to variable. So let's go back to the main method. As you can see, I added here a section where we transpile to C. We initialize the string builder and we add the header. In the header we add includes, and we initialize the main method. In the main method, we declare all of the necessary variables, and we initialize them to 0 because why not? Then we transpile our string, and finally we close the main method. At this point, we can just print it to see what we've got and make sure that it's all okay. The next step is to start GCC. If we set just the right parameters, we will be able to feed it input directly from Java application instead of first generating a file. In particular, this is the necessary flag to enable receiving input from console. Here we inherit error output so that in case something goes wrong, we just see it on our console. And then we start the process, we get the output stream, and we write our C code. Then we flush and close it and wait for the GCC to stop compiling. The output of our compilation will be stored in this place. Now, after it's done correctly, we are able to just run it like any other application and see the results. We inherit the I/O so that we can see all the output and write our own input whenever necessary, and we just run the application. So it's basically it. It's very simple. Let's see how it works. Oh, you can see that it's working perfectly fine. I wrote here a tiny program that implements Euclidean algorithm for greatest common divisor of two integers. We can try how it works. For instance, maybe first number is 12 and the second number is 14. Well, then you can see that the result is 4, which seems correct. Of course, this compiler is very simple. It essentially does nothing more than reading some simple language and translating it into C. You don't even need compiler to do that. You could very easily probably do this with a simple regular expression. However, this gives you a really strong basis for further development. Now you can add things like classes or maybe functions or type system or anything else. You can make really complex compilers. It's all up to you and your creativity and your skill. In general, making compilers is a very creative task. I will make many more videos that expand on this topic and show you lots of different ways to write programming languages. I will try to make compilers for different programming paradigms, for some esoteric languages, and maybe for Turing machines, string rewrite systems, or any other crazy ideas. Be sure to subscribe, and if you have some cool ideas of what kinds of languages you would like to see, you can leave a comment and I will try to implement your idea. Or if you have any question, I can of course try to help you. Thank you very much for watching. See you in the next programming series.